Welcome to 61D, the course where we teach you modern full-stack web development. My name is Aiden, and today we're going to be continuing our coverage of interacting with databases. Last time, we talked about how you can model data, and today we're going to actually interact with that data by creating data, reading from our database, updating data entries, and deleting data entries. We're going to be using the same starter code as we used in the part 8 video. You don't have to watch the lecture 8 video first, but I would highly recommend it. Either way, if you don't already have that starter code cloned, then you can click use this template and create a new repository and clone that locally. If you do already have that repository cloned, I would recommend pulling the latest changes because by the time that this video goes up, there will probably be some changes since I published the lecture 8 video a little while ago. Anyways, once you have it cloned, we can move to getting everything set up. In lecture 8, we worked on creating this database schema to model our blogging application. We created users, user settings, posts, and comments. Regardless of how your schema is looking, if you followed the whole video, it should look very similar to the solution schema. I would recommend getting started by overwriting the schema you wrote, and for this video at least, using the solution schema so that all of the queries we write should behave the exact same as the way I'm writing. If you want, you can save it in another file, but to start, I'd recommend copy over the solution schema into the starter schema. And again, that way you should be all set to go. It doesn't matter if you completed the data modeling stuff we did in the last lecture, you're ready to go with accessing your data. Again, next step is to make sure you've done the necessary setup. So install the dependencies, created your .env file, and created the respective databases. If you haven't, all you need to do, copy this code, go to your terminal application of choice, and paste it to run it. Install creates the two databases. So we have a starter database and a solution database. Then to get our starter database all set up for writing queries, what we're going to do is first push the schema onto the database, and then we're going to run our seed script just to set up some sample data so that we can start querying before we have to start creating data. So to do that, two steps. First is we're going to write fun db push starter, and that will set up our database for our starter code. If you already have something in the schema or some data, it might behave a little bit differently, but worst case scenario, you can just delete and recreate the database. And then once we have the database set up, we can run our seed script. So all we need to do is say bun starter / seed. Add, we've got to do bun starter seed.ts. And then it will run this seed script to make sure that we have everything going correctly. I will close out of this session. We can go bun db studio starter, like so, to pull up Drizzle Studio. And we can do that. And you should see that we have all of our tables set up, users table, posts table, comments table, and we just have some sample data created. I will write out more specifics on this setup process in the README of the repository. So if there's any issues that you run into, make sure you check there. And with that, we are ready to get set up and start writing some queries to take information and query it from this database. The way that we're going to interact with our database is through SQL, which stands for Structured Query Language. Talked about this very briefly in lecture 8, but all major relational databases are going to support interacting with that database using SQL. So Postgres, MySQL, SQLite, we're using today. If you know SQL, then you can interact with all of them, regardless of the underlying database structure. Technically, we're going to be writing Drizzle ORM code, but as you can see, one of the core philosophies of Drizzle ORM is that it maps extremely closely to the underlying SQL code, right? So as we are selecting from a table, performing a join, and having a condition, you can see it maps very closely to a SQL query. Fortunately, we can, even as we're writing Drizzle RM queries, have Drizzle log the exact SQL query that it compiles down to and runs. So as we are learning Drizzle RM syntax, you're also learning the basic syntax of SQL, which you could use in some other instance outside of Drizzle ORM, such as if you're using a language besides JavaScript, or you're just trying to do some basic analytics on your database by using SQL commands. Another important thing to consider when writing SQL is that it is a declarative language as opposed to an imperative language. Let's take a look at something like JavaScript, which is imperative. With an imperative language, you have to specify exactly how something is going to be achieved. So if we want to select some countries and some cities, we might have to write some loops and some conditional statements to achieve our end goal. With a declarative language, all we have to do is describe the end goal, and then an underlying query execution engine will determine how we will achieve that end result. This is a really good thing for you, especially as a JavaScript developer, because all of the query engine optimizations and all of the code which determines how to process things efficiently is all super, super high performance efficient C code compared to our much less performant and much less optimized JavaScript code. For this reason, anytime you can rely on SQL to do something for you instead of doing something in your application code, you should try to offload that work to the actual SQL execution engine. For example, something like sorting your results. You should specify the way you want your results to be sorted within the actual SQL query, as opposed to sorting them after they've already been returned from your query. There's a couple times that we'll encounter where we have to think about how the way we specify a SQL query can make it more or less performant to achieve our same end goal.